Hello friends, in this video we are going to discuss Biot-Savart Law. Biot-Savart Law is a very fundamental law in magnetostatics. As we know, magnetic field can be produced by a magnet or it can also be produced by a current carrying conductor. So from our earlier lectures, as we had discussed, a magnet have a north pole and south pole. Magnetic field originate from the north pole and terminate to the south pole. But this is not only a way to produce the magnetic field. There are another way, and that is the current carrying conductor. So this was the famous experiment performed by Oersted, and in his experiment he explains that if we have a current carrying conductor, then there is the existence of magnetic field around it, and it can be proved by putting a magnetic compass near this wire. As we know, a magnetic compass have a magnetic needle, and whenever this magnetic compass is placed in any external magnetic field, its needle shows deflection. So when we put this magnetic compass near the current carrying conductor, it shows the deflection. So what does it mean? It means that there is the existence of magnetic field near the current carrying conductor, and this was the experiment performed by Oersted. So since this magnetic field is produced by a current, that's why this effect is known as magnetic effect of current. So this effect is known as magnetic effect of current. So since we have seen that here the magnetic field is produced due to a current, so there should be a relation between the magnetic field and the current, and the relation between this magnetic field and the current is given by the Biot-Savart law. So according to the Biot-Savart law, to prove the Biot-Savart law, let us consider a current carrying conductor. So suppose this is a current carrying conductor and I is the amount of current flowing through this conductor. So let us consider a small current element on this conductor having a length dl. And now let us consider a point P where we want to find the magnetic field due to this current carrying element. So let this P is at a distance of r from this small current element, and theta is the angle between this conductor and this displacement vector r. So according to the Biot-Savart law, the small magnetic field, that is the dB, due to this small current element dl, depends on current flowing through this conductor, length of small current element, that is the dl, and the square of distance of point from the conductor. So in the vector form, the dV can be written as directly proportional to the I dl cross r divided by r cube. So since this dV depends on dl cross r, so the direction of B is perpendicular to the plane containing dl and r. Now we can write this dV as mu naught by 4 pi I dl cross r divided by r cube, and here this mu naught by 4 pi is a constant. So this mu naught by 4 pi is a constant, and this is equals to the 10 raised to power minus 7. The term mu naught is known as permeability of free space. Since we had considered the medium is the free space, that's why we are taking the mu naught. If the medium is not a free space, then at the place of mu naught there will be mu, that is the permeability of medium. So now the dV can be written as mu naught by 4 pi I, and since this is a cross product, so we can write it dl into r with the sign of theta divided by r cube, and we can modify this equation as a mu naught by 4 pi I dl. This r will cancel out with this r cube, so sin theta divided by r square. So this is the general form of a small magnetic field due to a small current carrying element on a current carrying conductor. Since the magnetic field is a vector quantity, so it has some particular direction. As we discussed earlier, the direction of B will be perpendicular to the plane of dl and r. But there is the another rule to find the direction of magnetic field, that is the right hand thumb rule. So according to this rule, if we have a current carrying conductor and if we put our thumb in the direction of this current and the fingers are pointing towards the direction of P point, then the direction of our curled fingers will give the direction of magnetic field. So that is the rule which we can use to find the direction of magnetic field. There are so many applications of this Biot-Savart law. As we will see in our next lectures, Biot-Savart law can be used to calculate the magnetic field due to a straight current carrying wire at any particular point P, due to a circular loop at its center and at any particular point P on its axis. So these are the possible applications of Biot-Savart law which we will discuss in the next lectures. Thank you.